Okay, we're going to go ahead and work on a couple problems to start you out. So I want you to watch this video. We're going to analyze what's listed on your handout as problem 41. And this is 47 here, but don't worry about it. It's the same graph. Okay, we're going to analyze these things. First of all, let's look at this. Let's look at this graph. We have a 0. Okay, let's put down where we have zeros. We have a 0 at the point 1, 0, and we have the point 3, 0. Okay, we have VAs at, and we have one at x is equal to -1, it's clearly marked, and one at x is equal to 2. Okay, we know that at the -1, the multiplicity is going to be, not m equals, m arrow, because we're talking about multiplicity here, not slope, is going to be an even, because we have converging behavior. Look at, they're going both up. And then at x is equal to 2, we have even, because again, they're both going down together. Now we look at y is equal to 1 is a HA. So we've got that made for us. And the y-intercept, so we need the point 0, 1 on our graph. Okay? So let's go ahead and see what happens here when we do this. Now, for the HA of 1, we need the ratio of the leading coefficients to be 1. Let's start building our graph now. Let's call this just thing R of x for lack of another name. And we'll start building our problem up. I'm going to start putting x plus 1 here. And I'm going to start out with squared. And then I'm going to put x minus 2 down here. I'm going to start out with squared because of the behaviors of those asymptotes. Next, I'm going to go ahead and put together my zeros. And I know I have 1 at 1. So here's x minus 1. And since it's a cross, I'm going to have probably a 1 here to start with. And then I have x is at 3. And so it's x minus 3. And I'm going to start out with a 1 there. And that's my first try at it. Okay, so if I go ahead and look at that, let's go ahead and work with my calculator at the same time. I'm going to open it up. And we're going to start to see what that looks like. Now we know that's not going to be correct because these are 2 and 2 and that's 1 and 1. So that's a problem. So I need to bring these up. I think I'm just going to make this one a cube because remember I need them to match. Okay, so I'm going to change that to cube. Okay. So here's my calculator. I'm going to go ahead and turn it on. I'm going to start plugging that in. Let's clear it, what I had before. So I'm going to do a big group. I'm going to do left parenthesis x minus 1. And I'm going to raise that to the third power. And I'm going to multiply it times x minus 3. And now I'm going to group the numerator. And then I'm going to divide it by the denominator. And I'm going to do x plus 1 squared. And see, did that group it right? I don't like that group. I'm going to get rid of that. And x minus 2. quantity squared. And we'll close that denominator. And let's go ahead and zoom standard. And let's see what it looked like. Okay, so far so good. Looks pretty good. Okay, so I'm going to check a value now. I just want to see if my asymptotic behavior is okay. So I'm going to go hit vars, y vars 1, 1. And I'm going to put in negative 100 just to see what my left behavior is. And I should expect like 1 point something. That looks good. And if I go ahead now and type in a positive 100, just using cutting and pasting, that looks good. So far so good. So let's see what's happening when x is 0. So let's go ahead and put in 0 here. We'll just delete that one and we'll put in double 0. 0.75, we have a problem because I want to go through 0.75. Now, let's just see. So let's take this calculator out of the way for a second. So when I put the value at 0, I see I get negative, negative 1 times negative 3. And that's going to be over 4. So I get 3/4. So r of 0 is 3/4. So the question is, what can I do with this? Now, your first temptation is going to be to put in, what can I multiply 3/4 by? Okay, 3/4 times something is going to be equal to 1, because that's what I want. And 4/3 is going to be your first try, and you're going to want to put 4/3 in here. Okay, so you're going to stretch your thing by 4/3, and if we do that, that's going to give you y at 0 is 4/3. But remember, that's going to change your HA, because 4/3 becomes my leading coefficient, with 1 being my leading coefficient. So that won't work. So that is going to be bad. So what else could we try? Well, let's erase that now. I know I don't like the erase, but for this one, I'm going to erase it. So what could we do at 0 to multiply this equation by 4/3? And I contend I'm going to show you something that would probably work. I'm going to make up what is called a non-zero factor. So I'm going to make up x squared plus 4/3. So when x is 0, this factor now will be 4/3. And a comes from this 1, so it's not going to screw up everything. But now if I looked at this, I have a problem. Maybe I have a problem, but maybe I don't have a problem. I made this 3 way back when. Could I just change this back to 1? Okay, so let's go ahead and see if that would work. Okay, now, I don't know if I can make a small enough eraser, but I'm going to come back in here and I'm going to try it. I'm going to try it. Okay, got it. I got rid of it. So I'm going to go back. And now when I look at this, let's say, wait a second. That's 1. That hits the behavior that I want. It's a cross. And I just put in the 0 factor. And what that did was it didn't change A, but it sure changed everything else. So that I have multiplicity total is 1, 1. Power here is 2. My numerator is a 4th degree polynomial. My denominator is a 4th degree. I think I'm just going to use that. Okay. Now I could have put this over x squared plus 1, but did I really need to do that? I think some people, so we did this problem here. Okay, we're done with that problem. So let's just kind of erase it, but let's go back to the calculator. And let's see if I can find my calculator. Oh, made something go big. Lesson plans. Oh, let's go find the rabbit. Okay, there it is. So now I'm going to go back to y equals. I'm going to change this 3. I'm going to just put 1 there. That's the easiest way to do it. And then in the numerator, okay, so here's the end of my numerator. I'm going to insert in a factor. I'm going to insert in x squared plus 4 divided by 3. And I'm going to group that. And I'm going to graph that. And for all intents and purposes, let's see, it looks to be the same. There's very little difference, right? If we check our asymptotic behavior, that doesn't do anything. That's just like a positive number as a factor always. Let's check, did it work? Did y So I'm going to go here and quit, and I'm going to say, what happens when we put in 0 again? And wow, we've got it. So let's go back to our graph now. I ended up just putting in what I call a non-zero factor. And what that did, that was a magic way to stretch my function right here at x is equal to 0. Okay, so hopefully that helped out. Let's go ahead and try one more example real quick. We're going to do this one faster. We're going to do this other graph, and we're going to see if it works. Okay, we're going to go through the step-by-step process like we did before. I'm not going to write all this information. I'm just going to start building. I'm going to call this P of X for just the name, and I'm going to build it as we go. So as you follow this, I'm going to go slower, but yet not as much writing. Okay, so I'm looking at how many zeros I have. Well, in my graph, I think I have a 0 at 1, and I have another 0 at -2. Those are my only two zeros. So I'm going to put x plus 2, and then I'm going to put x minus 1. I notice that I have a cross at 2, so that's good enough to be a 1, and I have a touch at 1, and I'm going to put a 2 here for starters. Asymptotes, x is equal to 3, x plus 3. It's divergent. I'm going to leave it alone. Next, x minus 4. It's convergent squared. Okay, so that's that. Then I go ahead and see what's the multiplicities. Okay, we're good with the multiplicities. I got 3 for the total number. I see y equals 3 is a HA, so I better go ahead and do this. Okay, I know that as I put in a big number, I'm going to stop for a second and set up my calculator. I'll tell you what, I'm going to stop, and everybody could stop. No, if I put in my calculator and you do it at the same time, we'll be okay. Okay, so you do it and I'll do it. So if you do it now and I do it, we'll match up. Go for it. Okay, I'm going to set up my numerator. Second, brace, left parenthesis. I forgot a 3, so let's put the 3 in here first. That's supposed to be in a numerator. So 3, left parenthesis, x plus 2. Okay, times x minus 1 squared. You're probably doing this faster than I am because you're better at it. Okay, I'm going to brace the upstairs, divide, I'm going to brace the downstairs, the denominator. My factors are x plus 3 times x minus 4 quantity squared. Okay, let's close that. Okay, I'm going to go ahead and graph it. Okay, so far so good. So far so good. So far so good. Okay, I think it's okay. So I'm going to graph end behavior, and I'm going to see if end behavior, remember, I'm going to go and do it in my home screen. If I did it in my other screen, I would find that we'd get a window error. So let's put in negative 1,000. Oops, oops, oops. I didn't put my Joop in here. Joop, negative 1,000. You say, why am I going to 1,000 this way time, not 100? Negative 100, just because I can and I feel like it, and I'm just changing different things. Okay, I needed a number a little bit less than 3. That's it. Now I want to check the positive and see if it's a little bit greater than 3. And so here we go. Let's delete that negative sign. Hit enter, and it's greater. I think that's good. Let's just check it at 0. Okay. And we'll just delete the 1. And I'm looking for a number a little bit greater than 1, maybe less than 1. Okay, that's close enough. I think that's good. We did it. Okay, let's go ahead and publish this thing, and then you have something to do for class for starters. And I'll do the second video as a separate one. Okay, so there's the 2 problems.